For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Being a debate addict like myself, we were discussing the flood and the heat problem. So I think for now we'll focus on those issues. And then eventually we'll open up the room, and you never know where these open mics head towards. So we'll keep it fun. Whoever wants to start, go ahead. David, you might have a question. You guys are all the guests. So, I've got a million questions, but you guys are the guests. So you guys can kick it off.
Yeah, sure. So I guess I'll kick it off. I'm starting to doze off to sleep, so I'll try and stay awake as much as I can. So we're going to be, so I'm, of course, as already mentioned, going to be debating Nephilim 3 on the flood. So I think the first thing we should do is try and sit down, do the math, do the dirty calculations, and try and figure out, first of all, how much heat is going to be released from catastrophic plate tectonics, from the movement of the crust, and from the flood itself. So figure out, and of course, accelerated radioactive decay. Figure out what the sum of the total, how much heat in all is going to be generated. Get that total, and then figure out what is needed, what cooling items would be needed in order to solve for this problem. So that's what I think should be done first.
Okay. So do you feel like the heat problem is then the number one argument against a global flood?
No, I actually think the genetics issue is the number one argument against the flood. But I think the heat problem comes at a very close second.
Okay. We could go to the genetic related arguments, but let's stick with heat. So when it comes to the flood, what about the heat and what about the numbers do you believe poses the biggest problem to the Genesis flood? Like, what numbers are you specifically referring to, and what assumptions are behind, I guess, your arguments pertaining to the heat?
All right, well, sure. So Dr. Snelling, of course, did his calculation for what the temperature is going to be for the if we had accelerated radioactive decay. We can calculate, okay, the temperature is going to be about 22,000 degrees Kelvin, which is about 3 times the surface temperature of the sun. And basically in response, he pretty much acknowledges that this is a significant problem, but kind of hand waves this away and say, okay, well, we see this evidence such as plutoniums, halos, and okay, so this might be a confirmation for accelerated decay, but this is kind of just hand waving away the obvious issue with the calculation that at 22,000 degrees Kelvin, the Earth would pretty much be vaporized.
Okay. So yes, I'm aware of the paper.
And
Snelling, I'm sorry. Go ahead, David.
Okay, yeah, and have you ever seen the paper called "A Physical Constraints Lockean Deluge"? Have you ever seen that paper?
No. Do you have it on hand? Did you want to?
Yeah, I can
What's
share.
What's the significance of the paper?
So basically, these are professors from Wheaton University, Wheaton College, whatever it's called, and basically they're trying to calculate, okay, the physical issues of it. I'm going to pull up the paper here, and I'll show you their calculations.
Oh, yes. Okay. Yep. I know which one you're talking about now. Okay.
Yeah. So they're calculating the rainfall method. Now, this was back in the 80s. This was well before flood geology and Dr. Snelling and all these flood models were developed. So these are admittedly a little bit dated. That needs to be updated a little bit. But the calculations are certainly there. For the rainfall alone, we can look at the calculation, how much is required to cover the highest mountains And here's a calculation and what the temperature would be at the surface and the temperature of the Noachian Ocean. And the answer would be 6,458 degrees Fahrenheit. Of course, they say the problem is, of course, much more complicated than this, but these figures demonstrate clearly the severe thermodynamic problems that must be solved if one wishes to deal with the biblical flood in a scientific manner.
Okay. I'm going to screen share real quick too, unless there's another couple points you wanted to make in regards to that. Okay. Go ahead. Yeah.
So these are two, I think, some of the big issues that we should talk about, whether or not this global deluge is even physically possible.
Okay, so I think though I'm just sharing screen right here, so there might be a bit of a lag, just for the time being. So I believe you're bringing up some valid criticisms that are deserving of discussion. Okay, and Godzilla Freak might have some input here. I'll start. So what you're saying is correct in terms of Dr. Andrew Snelling acknowledging the amount of heat produced, of course, just through meters per second plate movements, right, during the time of the flood, catastrophic plate tectonics. The friction alone would certainly create a lot of heat. Now, Dr. Snelling, though, as you did point out, David, he points to radio halos and fission tracks. Okay, what this is in a nutshell, and we've had Professor McQueen on for like a couple hour show going into the technical details on what radio halos and fission tracks mean pertaining to accelerated nuclear decay. It's pretty well just scars within the rocks themselves, indicating a lot of decay in a short amount of time. Okay, we could also look to helium in zircon crystals if you'd like to, but the point is, we do see the evidence in the rocks that at some point in history, okay, decay rates were accelerated. Okay, now we have the heat associated with accelerated nuclear decay, among other things associated with catastrophic plate tectonics. Okay, so how do we deal with that? Well, for one, and this is pointed out on page 194 of Rock Solid Answers. Okay. Radio halos and fission tracks are obliterated at relatively low temperatures.
Correct.
Okay?
So
if
that
there
means
has been a heat problem due to accelerated radioactive and nuclear decay, then we should not be finding these radio halos and fission tracks in the rocks today, but we do. And Snelling pointed that out in the papers you're referring to.
And if I could respond to that real quick.
Yeah, go ahead, David.
Okay, sure. So that's a little bit of a quote mine in and of itself, but he goes on and says the following: however, the reality of the existence of the halo must not have been an insurmountable problem if there has been accelerated decay. Incredible amounts of heat must have somehow been removed rapidly by a process or processes that we have not yet discovered or understood, for otherwise these rocks and the radio halos in them would have been vaporized. So translation is Dr. Snelling is doing the calculation saying, okay, here's 22,000, the overall calculation. The temperature rise would be 22,400 degrees Kelvin, which would vaporize the radio halos and all of this stuff that he is talking about. So obviously, because we see the radio halos that allegedly prove accelerated decay, there must have been some type of cooling mechanism that has not yet been discovered. So the point of the matter is there is still a significant heat problem associated with this model. Dr. Snelling acknowledges it and says that, okay, we still need to figure out what process or processes that would be needed in order to solve for this problem.
Right. So good points, good observations. So here's the thing. What we have in the rocks themselves, observable evidence in the rocks themselves that decay rates have been accelerated. Creationists would say the accelerated nuclear decay occurred at creation and then during the flood. Okay. Now the question is, okay, what mechanisms were at play to remove that heat? Okay. So we already know that decay rates were accelerated. Okay, we see that in the rocks. We see the scars themselves. Now, obviously, the ripple effect of this, as you're pointing out correctly, David, and I'm glad you are, the ripple effect is immense amounts of heat produced that essentially the argument goes, and correct me if I'm wrong, this amount of heat would have boiled the oceans.
Right.
The radiation as a result would have resulted in the death of Noah and the animals. And the crust itself would have been obliterated. It would have melted, essentially. Is that kind of how the argument goes based on those temperatures and those numbers?
Pretty much, yeah. I think that would be a good summary.
So now we have to discuss the mechanisms, okay, that Dr. Andrew Snelling is talking about in his papers, okay? So I've got a list of possible solutions, okay? Now, we weren't there during the flood.
Of course not.
Today we see the rocks. Today we see the rocks. We see the scars indicating accelerated nuclear decay. Now it comes down to plausible solutions in getting rid of that heat. Right off the bat, before I even go over these points, and then David, I'll give you plenty of time to respond. Right off the bat, okay, according to the flood model, heat itself is not a bug. It's actually a feature of the world. It's needed, right? Heat and energy are required, as I put here, to get the plates moving during the flood. Meters per second plate movements as compared to the snail paced movements of the plates the uniformitarians look to. Okay, the heat and energy would greatly help with that. Okay, and all we would really have to do is get the heat into space, where you've got essentially an unlimited heat sink that can absorb all that heat. Okay, so for one, I just want to point out heat isn't totally bad, as it's a feature of the flood. It's required. It's necessary. Okay,
absolutely. And I would agree that a global flood would absolutely produce enormous amounts of heat. So we can both agree with that.
Right. Now here's my question, okay, based on this point here, okay, and this comes to mind, is, are these numbers making any assumptions because remember, you never want to straw man an argument. For example, you'll find evolutionists oftentimes arguing against evolutionary creation, right? When we get into the genetics, they make arguments that assume we explain the majority of genetic diversity as the result of what? Mutations. No, we look to created nuclear heterozygosity. So obviously you want to argue against the model and not a straw man. So here's the thing. Are these calculations being put forth, being purported by the critics? Are they making any essentially unknowable assumptions about, let's say, the temperature of the Earth's core in the pre-flood world?
Well, I can show you Dr. Snelling's calculations if you want me to pull it up.
Right. Okay, yeah, I've seen Dr. Snelling's calculations, but there have also been some non-young Earth creationists coming up with their own calculations too, right? Saying that right.
So
yeah, go ahead.
Right. So when I do these types of calculations, I think I want to be as generous as possible to your model. For example, we know that the Bible says that the water was about 20 feet above the surface of the 20 feet above the tallest mountain peak. Now, obviously, no creationist is going to say that the highest mountain peak is Mount Everest, which is almost 30,000 feet. They would argue that it was much lower.
Well, I would say this. It's kind of like, it's not exactly the same, but it's very similar to the naturalist and pressing the naturalist on abiogenesis, okay, origin of life. Now, the naturalist does not have a solution to the origin of life problems, okay? They have come up with a number of explanations, possible solutions. Now, obviously, I would respond to those solutions by saying, hey, those solutions each bring a number of unsolvable chicken and egg problems with them, okay? But that's besides the point. They will still put forth solutions, okay? They don't necessarily know which solution is the solution that possibly worked in their hypothetical scenario, but solutions nonetheless. And that's what I'm pointing out here when it comes to the so-called heat problem, is we have the evidence. We've observed the evidence actually through predictions from the rate team before they even went into it. We have the observable empirical evidence of accelerated nuclear decay, fission tracks, radio halos, and helium, just to name a few. Now it comes down to plausible solutions. As long as we can provide some plausible solutions into how, let's say, we can take most of the heat and dump it into space, maybe much of the energy and heat produced during catastrophic plate tectonics, maybe during that year, okay, maybe it's still in the Earth's core today, right? How hot is the Earth's core? But one thing I want to point out, David, and then I'll yield to you. There's something called the Hypercane Model. And to me, this is very persuasive, okay? And given the effects of the Genesis flood, massive hurricanes during the flood would have actually taken up much of the heat into space. Okay, and this isn't post hoc ad hoc. I want to say this before you continue, David, because today we can see what? We can see hurricanes, and we can see how great they are at dumping heat and energy into space, okay? For example, here I've got jotted down, when a hurricane goes over the ocean, what happens? Well, the temperature itself actually drops. And not just a little bit, it drops significantly. Okay, David. So, you know, it's understood by most scientists that convection is a great way to move heat quickly. And that's all we're saying is as long as this heat, this abundant amount of heat is moved quickly and into space, okay, we know there would have been a lot of convection during the flood year. Look at hypercanes, for example. Okay, look at the fact that you've got a mile or more of water that can take up much of the heat. Okay, and that water can also protect Noah and the ark animals from the radiation, the excess radiation. I mean, they use water to block from radiation when it comes to nuclear reactors. So water is very good at protecting and shielding things from radiation. But here's the last thing I'll point out, and I've got it listed here. Okay, the fountains of the great deep. Okay, if you assume the either hydroplate model or catastrophic plate tectonic model, the fountains of the great deep would have actually involved supersonic steam jets that would have taken up, I would say, most of the heat up and into space. And like I said, all we have to do is provide plausible solutions as to how it's possible to dump most of the heat into space. Then essentially we don't have a problem. Now it fits like a glove. We got the evidence for accelerated nuclear decay in the rocks. And now we have plausible solutions as to how we can dump all that heat into space itself. Not to mention ice cold hail coming down and, cooling off the oceans slightly. But think about a massive pool. This is the last thing I'll say because all these things are coming to mind. Think about you got a massive pool. If you were to just dump boiling water or even just liquid hot magma into one corner of the pool, it's really not going to change the overall temperature of the pool itself much, even though that liquid hot magma is incredibly hot, right? And that's what you're looking at in terms of the flood when the entire earth is covered with miles worth of water. Okay, yeah, certain parts of the earth are going to be boiled. Certain parts of the earth are going to be incredibly hot. But for every reason why you'd have a hot spot, or for every reason why the flood is producing a lot of heat, you've got 10 reasons as to why that heat can be absorbed or removed. Now, I know I said a lot there, but it's a big topic. So I yield. Go ahead, David. What are your thoughts on that?
All right, sure. So a lot of stuff. Let's start with the idea that the water could have acted as some form of innovator, could have somehow protected Noah. And you brought up the idea of a nuclear reactor and how they use water as a coolant, correct?
Right.
All right, sure. So I have a question for you. How hot is the water inside of a nuclear reactor? Do you know?
So when we're using water in a nuclear reactor to protect and shield things, I would submit it's probably not quite as hot as the hot spots during the flood. Is that the point you're kind of getting at?
Yeah. Well, I'm just picking a number. How hot is the temperature inside the nuclear reactor? Can you at least give a number?
An exact no. I imagine you have the number in front of you. What's the number?
Well, let me ask you before I tell you, what would be the absolute maximum temperature for your model to work? Like, if it would be like, say, 600 degrees Fahrenheit, don't you think that would be too hot for your model to work?
Not necessarily, because let's just say let's say it's 300 degrees Celsius, let's say, okay, in a nuclear reactor. Now, when it comes to the flood model, though, that's why I'm not giving just one solution, so I'm not just saying it's only the fact that we have cold water coming up during the fountains of the Great Deep, okay, incredibly cold water to counterbalance the heat a little bit. Also, miles worth of water during the flood, helping to shield, let's say, Noah and the Ark kinds, okay? Also, the supersonic steam jets, the hypercanes, so on and so forth, the extremely cold hail coming down. It's all of these things in combination, right?
Right.
So it looks like you want to just go, you want to just take one and then
right.
kind of ignore the others.
Right. Well, I think
go ahead.
I think the best way to go about this is by, as it turns out, it is about 600 degrees Fahrenheit. That is about the temperature of the water in a nuclear reactor. Okay. So we're dealing with very hot temperatures there. The thing that we need to ask, because you brought up hurricanes and other stuff, again, I think it is important to kind of sit down, do the calculations. What is the heat problem? How much heat is going to be generated? And then we can use the models and say, okay, well, how many hurricanes need to be forming in order for there to be sufficient amount of heat that needs to be released? Let's see if that's a plausible mechanism by first going through the calculations and seeing all of just trying to figure all of that. Is this mechanism sufficient to cool this sufficiently?
Right. So what I would say is, when it comes to exact numbers, okay, now we can run the numbers based on a number of hypotheticals or a number of assumptions, but it's not just black and white when it comes to the flood model, okay? So that would make it difficult to have exact numbers, okay? Now here's the thing.
I'm not asking for exact numbers.
Right. Okay.
I just want to kind of like do ballpark figures. So, okay, this is the ballpark figure under this potential model. Because again, that's telling that.
Right. So here's what I would say. I'm going to go back to this. Okay. What we observe directly in the rocks is evidence for accelerated nuclear decay. We literally see the scars in the rocks themselves. Okay. Indicating that one or more periods of accelerated nuclear decay has occurred in the past. As creationists, we would say the creation event as well as the flood event. So we see that, okay? Secondly, since we see that, well, the heat and energy itself, I wouldn't even look to it as being a bug. I would say, okay, this is a strong feature of the flood. This is a necessary aspect of the flood, because in order to get those plates moving. Now, I would say this, just in order to explain the geology of the earth, catastrophic plate tectonics, okay, meters per second plate movements during the flood, okay, picture two cars coming at each other at 100 kilometers an hour, okay, the buckling that would result is significant enough to explain, let's say, mountains that we see today, okay, to explain the geology of the earth. But this whole uniformitarian, these processes that say it's these snail-paced movements of the plates, okay, the necessary buckling could not take place with uniformitarian processes in order to explain mountains and geological features to begin with. It would be like two cars coming at each other at 20 kilometers an hour. There's not going to be much buckling. But at 100 kilometers an hour, that's exactly what you're going to get as a result. So I would say that the catastrophic plate tectonics explains much of the geology of the earth to begin with. Like, how would you explain? Answer this after, actually. How would you explain through snail-paced movements of the plates under actualism or uniformitarianism? How could you explain, mountains with that assumption? But my point is, the plate movements during the flood, accelerated nuclear decay can help that. Heat and energy can help that, okay? Now, as long as through these number of explanations, okay, the Hypercane model, ice from hail, okay, helping to counterbalance the heat, as well as just the massive amounts of water to begin with, extremely cold water coming up through the fountains of the Great Deep, the supersonic steam jets. I mean, I can go on and on with these solutions. This can essentially dump most of the heat into space. Okay, those are plausible solutions. Now we can sit down and come up with some solid numbers. Okay, as to how this is going to work exactly. But the point is, we still see the scars themselves in the rocks, and that's significant evidence that accelerated nuclear decay has occurred. Yes, heat would result, of course, but here's X, Y, and Z as to how that heat can be dumped into space, or maybe much of the heat is still in the core today. Plausible solutions, a lot more solid solutions than I'm seeing from the naturalists in terms of abiogenesis. You know, at least we're coming up with some decent solutions. I mean, the abiogenesis crowd, for every solution that they come up with, it's chicken and egg problem after chicken and egg problem. So, you know, that's besides the point. But I brought up a few points there, David. Since you're my guest, take as much time as you need to address that. And then maybe I'll yield, because maybe Godzilla Freak or someone else on the panel wants to. I don't want to just dominate. So, David, go ahead. The floor is yours.
Yeah, sure, definitely. And so about mountain ranges forming, I think pretty much any geology textbook in the world will answer that question. Basically, what happens is that and I'll just use the Himalayan mountains as an example. Basically, the Andean plates and the Eurasian plate are colliding together, and that is forming the mountains that we see that the Himalayan mountains have. And in fact, we can use GPS data, and we can see that these mountains, in fact, are still growing today. So we're going to make a couple of hypotheses going to the scientific method. So a hypothesis is going to be that, okay, plate tectonics explains the formation of these mountains. And my hypothesis is going to be that this is caused by the colliding of the two continental plates. So the prediction that it might be making is, okay, if this is the case, then we should still see this process happening today. And it can confirm, using GPS data and other methods, that in fact, these mountains are still growing at a rate about 2 centimeters per year. So naturalism, the actualism, as it is known as today, the actualism explains this quite nicely. As far as
David, how, if I could just jump in real quick, how slowly are the plates moving, let's say, per year, according to actualism?
So I think it depends on which plate you're moving, exactly which plates. I know, just from the top of my head, I know the Australian plate was actually moving so quickly that recently that they had to update the GPS systems, because to account for the northward dripper, that the fact that Australia is drifting northward. Now,
right. So I would say I'm not disagreeing with the fact that, you know, the plates are moving. Okay, this is pretty well a fact, obviously.
Right.
My point is that according to actualism, okay, the plates are colliding into each other at snail-paced movements. Okay.
Correct.
So the buckling that would result from these uniformitarian processes, okay, they can't actually explain empirically the forming or the uplifting of these mountains, okay? The collision of these plates are supposed to explain the uplifting of these mountains, right? But what I'm saying is the meters per second plate movements during the flood could easily explain how, through catastrophic plate tectonics, these mountains are formed. That's why I'm using the example of two cars coming at each other at 100 kilometers an hour, okay? The buckling that would result, okay, is significant enough where you're looking at two cars coming at each other at 20 kilometers an hour, you're not going to have any buckling. You're not going to have anything as a result, really. So my point is catastrophic plate tectonics, which we are assuming during the flood, that is our model, can better explain the mountains to begin with. And what helps the plates move that quick? Heat and energy, which the evolutionists say is a problem. But I've already given, I think, 4 or 5 perfectly plausible solutions into how that heat can be dumped into space. Maybe some of it's still in the core today, and I don't want to repeat myself, but go ahead, David, go ahead.
Yeah, sure. So again, we know that plates movements, tectonic movements, they don't happen at a constant rate. We do know that they can speed up and slow down. That's pretty much well known. I
agree, but overall, still slow. Obviously, it's
right,
not constant, but it's also not meters per second movement of the plates, right? Like catastrophic plate tectonics would purport or propose, right? It's still overall slow. And here's the thing, though. We would assume catastrophic plate tectonics, rapid movement, okay, rapid meters per second movement of the plates during the flood. Then it would slow down to what we see today. So therefore, if we're looking at the plates moving today and assuming that that's how it's always been, okay, you know how uniformitarians will say that the present is the key to the past. Well, that's based on a very faulty assumption, because to begin with, I am purporting that snail-paced movements of the plates that we see today cannot explain the necessary buckling and uplifting of the mountains, while catastrophic plate tectonics can perfectly, actually, and leads to testable predictions in terms of these massive slabs of cool rock that have been found under North America, I believe it is, itself, through rapid subduction. This was predicted by Dr. John Baumgartner and then discovered years later when they came up with the field seismic tomography, right? So how do you explain these massive slabs of cool rock, where if uniformitarian thinking and actualism were the case, then these slabs of cool rock should have at least heated up to the temperature surrounding the slabs, or even melted, right? This is confirmation of rapid subduction just thousands of years ago. How would you explain that? And I know I went on for a while there, so I'll mute and go ahead, David.
Okay, yeah, sure. I want to give Andrew a moment to talk. So, Andrew, do you want to kind of try and answer that real quick?
Yeah, I guess I unmuted because I actually had a question for you, Standing. So I guess I'm not entirely familiar with the concept of catastrophic plate tectonics, but I believe it only goes back as far as say the supercontinent Pangea. Am I correct in that assumption?
That's a very good question, actually. If we went into the technical details of catastrophic plate tectonics, we would actually put the pre-flood supercontinent as being Rodinia, and then Pangea actually being a temporary supercontinent during the flood, during catastrophic plate tectonics. And even the uniformitarians look to Rodinia as a prior supercontinent to Pangea.
Right. Or I guess I would say there's also, according to uniformitarianism, been previous supercontinents and other continents before Rodinia even, right?
But then that is actually based on a number of assumptions, unknowable assumptions, essentially, that we could get into. But I will say this, to expand on what I was saying, in that our model that says Rodinia was your first supercontinent, Pangea, a temporary supercontinent, okay? We are looking to, obviously, this model of catastrophic plate tectonics, where the continents are moving at rapid paces through the flood waters. And to explain it the best way I can, the pre-flood ocean crust, okay, it's dragged down into the mantle. And this is what I was saying earlier. This is subduction process, okay? So the prediction was by Dr. John Baumgartner that the ocean crust, okay, if this model has any truth or validity to it, should still be cold, since according to this model, okay, this only occurred thousands of years ago, this rapid plate movement, okay? Now, even though according to this model, even though this would have descended into the deep hot mantle, okay, it should still be cold if it only happened a few thousand years ago. And then seismic data from NASA, as I was pointing out earlier, they've actually revealed these enormous slabs of cool rock, okay? But if you're thinking about down in the core, okay, it should actually be warm or melted. But this turned out to not be the case. And this was pretty phenomenal evidence and confirmation of flood geology, because it was a future testable prediction. And David, what are your thoughts on that too? And then we can also move on if you'd like, because I know Andrew doesn't have all night.
I like
on
that.
geology for an hour. But I will say this. Andrew, David, whatever you want to say to that. And then Godzilla Freak, he probably has some input on this too. And like I said, I don't want to hog the mic. So go ahead. I yield.
Yeah, sure. So I'm about to go to bed because I'm literally, I am sorry. I was kind of falling asleep as you were talking. So I didn't quite catch everything you said. It is almost 2 o'clock where I am.
Hey, listen. We just had a solid 45 minutes of technical discussion on the heat problem and plate tectonics and predictions. So I appreciate that. And I always appreciate your willingness to dialogue and have these important discussions, especially on the details of these models, right, David? You know, I think it's important to have more discussion on the technical aspects of these models, and the heat problem being one of them. Godzilla Freak, did you have some input before David had to get out of here?
Oh yeah, I just want to make a point on the mountains, where David made the point that, hey, the mountains are still rising, right? So it shouldn't be a problem. I'm just a bit tired here. And what I want to say regarding that is that it's not like the end of the process that's hard, right? Rather, it's like the start, when the mountains first form. That's when it's really hard, when they're moving slowly. So you can respond to that if you like.
I'm not quite sure what you're saying.
Right, so like it's easy to have the slow plates continue to grow a mountain that's already there. But to form the mountain in the first place, that's what's more difficult.
Okay, so basically, are you arguing basically that the rate of the collision is too slow for it to have been able to uplift and form a mountain as when they first collided?
Yeah, something similar to that.
Okay, so what do you think is going to happen once those two plates end up colliding?
Well, I'm not sure what would happen, but I'm just saying it wouldn't explain the mountains forming exactly the way they do, as well as if they moved more quickly.
I mean, it explains things just fine. Okay.
Well, I would have to read a bit more into that, but
okay, so yeah.
Well, it seems like there's just not enough.
Yeah, so I'm just going to quote right here from the Geological Society, UK. So basically, quote, 225 million years ago, India was an island situated off the Australian coast and separated by Asia from the ocean. The supercontinent Pangaea began to break up 200 million years ago, and India started a northward drift up towards Asia 80 million years ago. And India was 6,400 kilometers south of the Asian continent, but moving towards it at a rate about 9 to 16 centimeters per year. So at this time, the ocean floor would have been subducting northward beneath Asia, and the plate margin would have been a convergent ocean continental one, just like the Andes today.
Uh,
So yeah, basically, the Eurasian plate was partially crumbled and buckled up above the Indian plate, but due to the low density and high buoyancy, neither continental plate could be subducted. This caused the continental crust to thicken due to folding and faulting by impressional forces pushing the Himalayas and the Tibetan plateau. The continental crust here is twice the average thickness at around 75 kilometers. The thickening of the continental crust marked by the end of the volcanic activity in the region, as any magma moving upwards would solidify it before it could reach the surface. And the Himalayas are still rising by more than 1 centimeter per year as India continues to move upward into Asia, which expands the occurrence of shallow focus earthquakes in the region today. However, the forces of weathering and erosion are lowering the Himalayas at about the same rate. The Himalayas and Tibetan plateau trends east-west and extends for 2,900 kilometers, reaching the maximum elevation of 8,848 meters. So, end quote.
yeah, so
So yeah,
like again, I'm not saying that like you don't like come up with an explanation. I'm just questioning whether or not it's adequate to explain what we see. Right? So maybe I'll just find out on my own. I'll try to look up if I can see some form of calculation for if there is enough force generated from the initial collision to cause what happens.
If I could respond to that real quick. So we're not denying the fact that the plates are moving right now at very slow paces and the mountains are still rising at uniformitarian numbers, really, essentially, right? But it's the initial uplifting to get mountains that high is what we are saying, because we're looking at the current rate of movement. What did you say it was? It's about, I think overall on average, it's about 10 centimeters per year, the plates themselves, okay? So the point is, let's take Indian, Australian, and Eurasian plates, okay? Now, at only 10 centimeters per year, okay, at that movement, the collision of these two plates, okay, could not have been sufficient enough to push up the Himalayas. And to make it easy and understandable for everybody, that's like two cars colliding into each other, traveling at 1-2 kilometers an hour. Okay. There's not going to be any buckling. There's not going to be any significant effect as compared to this meters per second movement or two cars traveling at each other at, say, 100 kilometers an hour. What would that result in? Well, it would result in rapid buckling of the rock strata that could have pushed up those mountains, okay, to where we see them today. Now we see today, okay, because catastrophic plate tectonics is a thing of the past, right? Now we see uniformitarian processes. Okay, yeah, so we still see the plates moving a bit. We still see the mountains rising a bit, obviously, because the plates are moving very slowly. Okay, but it's the initial catastrophic plate tectonics that can actually explain sufficiently the rapid buckling of the rock strata. Okay, uniformitarian processes, like you're saying, the 10 centimeters per year cannot explain the rapid buckling of the rock strata to push up those high mountains. But the most important point is the cold slabs prediction, that if this were the case through catastrophic plate tectonics, we should find these cold slabs, and we have found these cold slabs. And science, David, you would agree, is all about future testable prediction. Wouldn't you agree with that?
Yes, and of course falsification as well.
Right, exactly. So think about it. When that prediction was made by Dr. John Baumgartner, it didn't have to come back to be true, right? Maybe those cold slabs weren't discovered, and therefore rapid subduction, okay, would be not as valid as with the confirmed prediction is the point. And this was years before. Dr. John Baumgartner, I believe is a geophysicist, and he's done all this modeling. And the Bible itself says that the waters were all gathered together in one place, and therefore the land would be in one place. And catastrophic plate tectonics and the supercontinent was actually proposed by a creationist even before uniformitarian scientists hijacked the idea. This was proposed years ago. I think it was like in the 1800s. His name was Antonio
Pellegrini.
I've got it here somewhere. What was that? Oh, yeah. Was that you, Andrew?
Yeah, Antonio Pellegrini or something like that.
Yeah. Antonio Snyder Pellegrini, I believe it was. He published his theory. It was in French, though. And I don't know if it was ever translated it into English, but he proposed catastrophic plate tectonics and the supercontinent based on the Bible in Genesis talking about what seems to be a supercontinent, because it talks about the waters gathered together in one place. Therefore, you'd have all the land essentially in one place as well. Which is interesting. I just Google history of plate tectonics, and you'll see Antonio Snyder pop up. Antonio Snyder in the 1800. Oh, actually, right here in his image, 1859. So, yeah. Go ahead. I know you're getting tired there, David.
Yeah, I'm definitely getting a little bit tired, and we could definitely pick up this topic for another day. If you could send me some information with those cold slabs, that'll be fantastic. I would love to read about it. But I'm literally falling asleep right now.
Hey, it's geology.
Geology. I'll tell you, geology is my least favorite science. I literally fell asleep in geology class. I would much rather do biology and genetics than look at rocks.
Well, you are a biology major now, right?
Yes.
All right. Well, you know what? It's been exactly an hour. So we went an hour into geology and heat transfer, the so-called heat problem, testable predictions. Therefore, maybe this is a good way to segue into the next topic, and then we will open it up because I know there's a few people that are dying to get in. So, David, I know you're tired. It's late for you. You've got a debate to prep for next week, and probably another 100 debates after that. So, did you have some final words?
Don't forget to come to the Neff debate next Friday night at 9 p.m. on Standing for Truth channel. I think it'll be fun to do a standalone discussion just on the heat problem, like detailing where we can, but I was kind of planning on doing some calculations of my own and kind of calculating, okay, how much of this could theoretically happen and all of that. I think it'll be having more time to actually prepare for the actual calculation and the actual mathematics. That'll be a nice conversation to have.
All right. Well, I appreciate it, David. I appreciate your time. I'm glad we could have this talk on the Genesis flood, the heat problem, and testable predictions associated with CPT and so on. So next week's going to be fun. Battle of the Neffs, round 2, the sequel. So make sure you're here. We're going to have a lot of fun. Then an after show over on David Neff's channel. So thanks for doing it, Neff.